Lesson 3. Fingerprint testing. Fingerprinting is a method used in forensic science to identify individuals based on the unique patterns and ridges on their fingertips. Here's how it works. Fingerprint patterns. The ridges on our fingertips form distinct patterns that are unique to each person. There are 3 main types of fingerprint patterns: loops, whorls and arches. Loops have one or more ridges that enter from one side of the fingerprint and exit from the same side. Whorls have circular or spiral patterns. Arches have ridges that enter from one side and exit from the other side without forming a loop or whorl. The skin of the fingertips secrete, which means release, sweat and oils, which leave behind an impression of the pattern as a residue on any surface they come into contact with. They can be altered temporarily by burning or cutting the skin, but the original pattern will always come back when it is healed. Each finger or thumb will have a separate pattern. It isn't like a copy and paste on each digit. Collecting fingerprints. To collect fingerprints, a person's fingertips are pressed onto a surface, such as an ink pad or a special fingerprinting device. The fingertips are then rolled onto a fingerprint card or a digital scanner to capture the unique patterns. Matching fingerprints. Fingerprint examiners compare the patterns of a collected fingerprint with known fingerprints to determine if there is a match. They look for similarities in the overall pattern and the specific minutiae points. If there's a match, it can be used to identify the individual associated with the fingerprint. Fingerprint database. Law enforcement agencies maintain databases of fingerprints, such as the Automated Fingerprint Identification System, AFIS. These databases store fingerprints from individuals, including those who have been arrested or convicted of crimes. When the fingerprint is collected at a crime scene, it can be compared to the fingerprints in the database to identify potential suspects. Fingerprinting is a reliable and widely used method of identification in forensic science. It's considered a valuable tool in solving crimes and linking individuals to specific activities or locations. Fingerprint biology. The biology behind fingerprints lies in the development of the skin's ridges and the sweat glands present in our fingertips. 1. Skin development. During fetal development, the skin on our fingertips forms ridges and valleys. These ridges are determined by genetic factors and are unique to each individual person. Even identical twins would have different fingerprints. The patterns of ridges remains constant throughout a person's life, making fingerprints a reliable form of identification. Friction ridge skin. The skin on our fingertips is known as friction ridge skin. It's different from the skin on any other parts of our body because it contains a higher density of sweat glands and has a unique pattern of ridges and valleys. These ridges increase the friction between our fingers and objects, allowing us to grip things more effectively. Sweat glands. Our fingertips have specialised sweat glands called eccrine glands. These glands produce sweat, which helps regulate body temperature, and this is one of the reasons our fingers and toes get cold and icy before the rest of the body. When we touch a surface, the salts and oils from these glands are transferred onto the surface, leaving behind a residue. So the sweat and oils produced by our fingertips mix together and create a unique pattern on the surface we touch. This pattern is what we commonly refer to as the fingerprint. The ridges and valleys of our fingerprints help us leave behind a distinct and identifiable mark.